Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to the introduction of what an antiderivative is. So just like all those years you spent learning how to add, then later you learned how to subtract, well, you've been learning how to derive. Now we need to learn how to antiderive. Okay? So your function f is called an antiderivative of f, and yes, I did mean to capitalize versus not capitalize, on a to b if f of x is equal to f of x for all x in a to b. Okay. So if f of x is 1/3 x cubed, it would have a derivative of x squared. If g of x was 1/3 x cubed plus 500, it would have a derivative of x squared. So do you see how they technically both have the same derivative, but they were not the same function to start with? So if you start with a derivative and you go to find the antiderivative, you have to account for that fact. So you're going to get the function plus c, because we don't know if there was a constant at the end of it or not unless they were giving us more information. Okay? So let's say you had a derivative of 2. Okay? That's saying the slope was 2. The slope was always 2. Well, the slope was always 2 on a linear line, so capital F of x, the antiderivative, before we derived it, would have been 2x. But we don't know the y-intercept because they haven't given us any extra information, so there could have been a constant at the end of the equation. Okay? So let's say we had 4x cubed. Well, the antiderivative of 4x cubed would have been, well, so deriving, we went down the degree. So here we're going to go back up, right? So x to the 4th, and we can think about it, 4 times 1 is 4. Yep, x to the 3rd. But there could have been a plus c. Could c be 0? Absolutely. Well, what if the derivative was sine of x? Well, sine is the derivative, well, negative sine is the derivative of cosine, so positive sine is the derivative of negative cosine plus a constant. Okay. What if f of x was 1 over x? Or x to the negative 1. Now, this is a derivative, right? And if I add 1 back, then I get x to the 0, which is a constant. The derivative constant is 0. So I can't do that. I can't think of it. It wasn't an x, not a normal x. If you recall, 1 over x was the derivative of the natural log. And technically, you're supposed to have the absolute value signs because you have to have something greater than 0 there, right? Okay. So I'm not really wanting to get into any big rules here. I'm just kind of want to introducing what the idea is. Now, what if they tell you lots of things now? Let f of x equal 12x squared plus 6x minus 4, and f of 0 equals 4, and f of 1 equals 1. Find f of x. Okay. All right. Well, we first have to get the first derivative, right? So if this was 12x squared, it would be x cubed, and 3 times 4 is 12. If this is x, it would have had to been x squared, and 2 times 3 is 6. This would have been 4x, and this would have been some constant. And then x to the third, this would have been x to the fourth, and 4 times 1 is 4. X to the third, and 3 times 1 is 3. X to the second, 2 times 2 is 4. Whatever this constant was could have had an x after it. And this would have to be a different constant. Now I had to put subscripts, so I don't know what they are. Okay. I do, however, know that 4 will equal 0 to the fourth plus 0 cubed minus 2 times 0 squared plus the first constant times 0 plus constant 2. 0 plus 0 minus 0 plus 0, that all goes away. 4 equals constant 2. Now that I have that, now I can solve for constant 1. 1 equals 1 to the fourth plus 1 to the third minus 2 times 1 plus the constant times 1 plus 4. So 1 equals the constant plus 4, so negative 3 equals that constant. Okay, so we have our equation. F of x equals x to the fourth plus x cubed minus 2x squared minus 3x plus 4. Okay, so just understanding that the antiderivative is what you would have had before you derived, and that there could have been a plus c on the end. That's really kind of all we're getting to with this introduction here. Future videos are going to get into all the rules and the patterns, because we're going to have to reverse engineer that product rule, that quotient rule, and the chain rule. So just the simple exponents, that's one thing, but we're going to have to reverse engineer every other kind of rule that we had.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.